Hi, welcome to the Exploratorium in San Francisco. We are coming to you live from our new location at Pier 15 along the Embarcadero in San Francisco. And this is the first webcast from the new Phyllis C. Wattis webcast studio. I'm Robin Higdon.
And I'm Ron Hipschman.
And today we're going to be giving you an update on the Mars Curiosity rover. It's about 466 days into its 2-year mission, and we've already had some success.
Yes. They've already determined what? You tell us what they've determined.
Well, they've determined that there was actually water flowing on the surface of Mars at some time in the very distant past. And we believe that means that Mars could have been habitable for life. Microbes, probably.
Probably only microbes. No little green men and women.
No evidence of that so far. The Mars rover is continuing, though, to look at the geology to try to determine the history of the planet Mars.
It is. Now, I wanted to tell people that we're going to show you some photos today. Those photos that are available to you too. If you go onto the web, you can go to this website, mars.jpl.nasa.gov, and all of these photos you can download for yourself and look at them in much higher resolution than you'll be able to see them in our webcast. So, and there's a lot of information here. You could get news updates. There are videos and all kinds of interesting activities. So I want you to go after the webcast, go to this website and check it out. It's really great. So let's begin. Where is the Curiosity rover right now? The Curiosity rover landed, as Robin said, 466 days ago in Gale Crater. And I have a model of Mars right here, a Mars globe. And Gale Crater is very close to the equator, right there at the end of that tip of that arrow. It's a pretty big crater, and you see it here on the screen right now. They believe that there was water flooding the floor of Gale Crater many, many millions and billions of years ago. The Curiosity lander landed sort of in the middle of that ellipse that you see right there. You'll notice that below the ellipse you see a black dark line. Those are sand dunes, and we'll talk about those in just a little bit. So that is where the Curiosity rover is now and where it will stay for its entire life. The idea here is that Curiosity is going to eventually drive and climb up that peak that's in the middle of the crater. That peak is called Mount Sharp. And so that's the target for this mission. The mission is nominally a 2-year mission. But we hope that the rover will last longer. As a matter of fact, there are still rovers on the surface of Mars that are still running. The Opportunity rover is still on Mars after how many years now? It must be 8 years now.
Yep, and that was originally about a 1.5 year mission. So,
90 days.
So these things are built to last, and Opportunity is sending back still great images. And you can, again, look at the same webcast to learn more about Opportunity.
Every picture that Opportunity and its sister rover Spirit, which has since stopped functioning, is on our website, actually. If you look on our website, every raw photo is there, over 250,000 of them now. You can go onto the JPL site and find all the raw photos for Curiosity as well. So what happened? Where were we? The last time we talked to you, it was about middle of March, end of March. And at that point, we were going to start losing contact with Mars because from our viewpoint, Mars was going to be behind the sun. So here in this slide, we can see that the sun is in the center of the slide. The Earth is on one side of the sun, and Mars is on the other side of the sun. Now, from our viewpoint on Earth, what we look out and see is we see the sun in the sky, and what we'll see is Mars. Here you go. Mars is now moving behind the sun. From our point of view, and right about there on April 17th, when Mars is behind the sun, we don't communicate with the rover. Why? Because at that point, when we're sending commands to the rover, the sun is in the way, and the sun can, because it's giving off all kinds of radio waves, can garble those commands. And the last thing you want is to garble a command to a rover and have it drive off of a cliff or something like that. So that becomes a quiet period where the rover is just resting and taking data about its environment, about the weather on Mars and the radiation environment on Mars. And the scientists are busy back here analyzing all of the data that had previously arrived from the rover. So during that time, during the conjunction between the sun and Mars, There was no activity going on between us and the rover. There's some other photos that we got between August and September. They took a series of pictures from the orbiter, orbiting going around Mars, and here you can see this is of the aeroshell that was part of the back side of the spacecraft. It flew off once they didn't need the parachute anymore and landed independently a little distance from the rover itself. But you can see here that the parachute has been blowing in the wind. So there are indications here of active processes that will shape things like the sand and the geometry and the things on the surface of Mars. And here you can actually see that parachute blowing around between August 12th and January 13th. Again, that was, sort of at the beginning of this year. But that's a new photo that was just released. So we can see Curiosity on the surface as well. Here is a photo, and this one's a little bit hard for you to see at home, I think. But there's this splotch, dark splotch over on the left-hand side of the frame. That's where the rover landed. And it's called Bradbury Landing Site, after Ray Bradbury, who wrote the Martian Chronicles. And since then, the rovers have been driving a little bit. And I don't know if you can see it in here, but there are two little tracks that are headed to the right on the frame here, to the east. And the Curiosity rover is now, again, hard to see. It's a little bright spot. Let me zoom in on it here.
And that's the actual rover.
That's the actual
not an
rover.
Animation.
Right
that's
there.
Not a drawing.
That's the actual rover. You can see the tracks from the rover moving over here. And the rover is now sitting in this area. And you can see there's a bright area in the upper right-hand side of the frame there. And there's different geologies right here. And this is an area that, what do they call it? Glenelg.
Glenelg.
Glenelg. Which is the same backwards and forwards, by the way. And Glenelg is this interesting geological area that they went and studied, and they've been there from the time, almost from the time the lander landed until now. They just left that site just about a month ago.
Right, it was pretty interesting because it was an area with 3 different kinds of rock and soil met. So from that one spot,
yes,
they could test 3 different kinds of rock and soil.
Right, you can see the lighter area up in the upper right, that's called Yellowknife Bay, and then the area on the left-hand side of the screen. Then there's this darker material, this strip of darker material coming in from the bottom of the screen. 3 different geologies, 3 for the price of 1. Very exciting to go there, and you can you don't have to drive very far to see these different geologies.
And I would say Yellowknife, the lighter patch area, is where they actually made the drills that determined that there was indeed water.
Right.
So that's a really important spot. But
let's take a close-up look at that, actually.
Okay.
So here's sort of a black and white picture. And you see here it's labeled there Yellowknife, that it's a little closer in than the previous shot. And there's 2 spots labeled here. The one in yellow is labeled John Klein, and that was the first spot that they drilled into the surface of Mars with the drill on the front. We'll show you that in just a bit. Then they chose a spot nearby just to confirm what they were doing before. They chose another spot. This one was called Cumberland, and they drilled right there as well. The Cumberland's written there in kind of a cyan color. So you can see the Yellowknife Bay area and the Glenelg area in general there that they started out in. So here is the drill on the surface of Mars in the John Klein area, and this comes in, the drill comes in and it sits on the surface, and it can drill there for a couple of hours. And let's take a close-up look at that drill, actually. There's a close-up, and this one was taken, we took this one down at JPL. We were able to visit engineering model of the rover, identical twin to the rover that's on Mars, except it's down at JPL on
So
Earth.
let me just say, JPL is Jet Propulsion Laboratory.
Jet Propulsion Laboratory.
It's in Pasadena, California, and they're the people who are actually operating this mission. So the scientists who are driving it around and where they're determining what to look at next, they're all sort of stationed at JPL.
And the reason they have this model at JPL is in case anything goes wrong on Mars, well, you can't send a repair guy up there. Well, you work on the model down at JPL. It's a fully functional model. They've drilled into rock with this drill as well, and they can play around with the model and figure out what's going wrong up on Mars and then figure out how to fix it. So this is the drill, the business end of the drill. You can see it has kind of a diamond-shaped tip, and there's actually spare drills here. There's two or three spare drills on the front of the rover in case they wear it out. So let's take a look at the actual hole that they drilled, the second one. This one's Cumberland. You can see it's kind of a pebbly soil here, and I'm going to switch here, and we're going to go back and forth. And here you can see the before and after pictures. Notice that the subsoil is a different color than the soil on the surface there. It's kind of gray, as opposed to being this nice golden brown color that we normally think of as Mars. And they were able to use that dust as well. They take that dust that's drilled from inside the rock and analyze it inside the lander itself using several instruments that we'll talk about one of them in just a couple of minutes. There's another instrument that's mounted on the mast of the rover. Oh, I didn't mention that.
Can we show them this?
Yeah, let's show them that first.
Go ahead.
You tell them.
Oh, just to try to understand the size of the hole that we were seeing. So this is the width of the drill bit. This is actually the size hole that it's drilling. And that's the depth. So that's actually how deep it goes. So the holes aren't very big.
It's about a 3/4 inch diameter hole and
but
about
it's enough.
2 inches deep.
Okay.
So they can, but that's pretty deep to drill into a rock. It takes them a couple of hours to drill a hole that deep. So what you're seeing in this slide is not only the hole and the dust, but you'll notice that there's a little row of dots in the dust above. Now on the mast where all the cameras are on the top of the rover, I only have a little tiny picture here. I have a little tiny model. On this mast right here, up here in that little box up there, there is something called the cam. Right in that little thing is a little telescope, and in there's a laser, and they can zap surface rocks on the surface of Mars, and the gas given off by the vaporizing of the rocks is then analyzed by a spectroscope in the telescope on that mast, and that can then tell them what kind of elements are on the surface of Mars. And so that's called the chem, and that's what blasted that little pile of rubble, the dust out on the outside of the hole, and they were able to analyze the chemistry there. So it's a really cool experiment to think that we actually have a little laser on that thing. Just in case there's Martians, we can also defend the spacecraft, I think.
It's the first rover that could defend itself.
That's right. So let's take a look at now where the rover is going, because once they finished here at Cumberland, it was driving. They have to get to Mount Sharp, and that's a long way away. So here you see a slide, and in this slide you can see the actually, I have to look and see myself. You see the Bradbury landing site with the yellow dot, and then next to it is where John Klein and Cumberland are, just a short distance away. And they drove actually east to get to that Glenelg area where John Klein and Cumberland were. But that's not where they eventually have to go. They eventually have to end up really near the bottom left of this screen. There's a blue dot there that's labeled Mount Sharp Entry. And that is, they have to go around those sand dunes. You see that dark row of sand dunes underneath? It's a diagonal slash of sand dunes. They can't cross that with the rover, so they have to go around it. So you have to go about 5 miles, or about 8 kilometers, southwest until they get to the end of that dune field. And that's where they're going to end up turning. They're going to make a left turn there, and they're going to start charging up the mountain. And as they go up the mountain, they'll be hitting younger and younger and younger geological deposits. So they'll be able to look at the geology of Mars through time and find out how water has changed the environment on Mars as well. So that's the target. It's a long way to drive, and they don't drive very fast. When we were down at JPL, we were able to go to the Mars Yard, and in the Mars Yard there was this rover. And this rover here is not called Curiosity. This one is called Scarecrow. This rover is only meant to test driving. The rover operators down at JPL can use this rover and put it into situations, surround it with rocks, figure out how to get out of situations. If the wheel gets stuck in sand, they can use this rover and try to figure out how to get out of situations. The reason it's called Scarecrow is that the only thing on this rover is the driving mechanism. There's no instrumentation, there is no cameras, there is no computer even on this thing. It doesn't have a brain.
Oh.
That's why it's called Scarecrow, because from Wizard of Oz. Get it? Okay. So Scarecrow, let me put this in motion here, because I want to show you how Scarecrow moves.
It
There we
looks
go.
like
Now
it,
the Scarecrow's moving on, and they let me put a big rock in front of Scarecrow. So I put this big rock because I wanted to see how well it can navigate large obstacles. And notice that Scarecrow can actually, and Curiosity, can go over very large objects that are almost the size of the wheel itself. Notice that only one wheel is off the ground. All of the other 5 wheels are still on the ground here, and that's this suspension system that they have on the Rover called a rocker bogie system.
yeah.
Now the center wheel is going to go over the rock.
Yes, and it's moving very slowly, but I would say that is the metal to the pedal. That is about as
It's
fast.
the pedal to the metal.
Pedal to the metal. That's what I meant.
This is full speed.
That's it. Full speed
Floored.
ahead.
Pedal to the metal. This is as fast as the Rover can move. So just to give you an idea of, remember it has to go 5 miles or 8 kilometers just to get to the Mount Sharp entry point. This is how fast it goes.
Right, and so that's part of the reason too, in the next period of time, it'll be mostly driving. It might stop a little bit along the way, but they just want to get it to Mount Sharp as fast as possible. At this speed, it's going to take a while.
This is as fast as possible. The 4 corner wheels can steer, and the 2 center wheels cannot. And these are actually the same wheels that they have on the Rover. And this Scarecrow is designed to have the appropriate weight so that on Earth it would have about the same
Pressure.
the same pressure as and the same friction that you would see on Mars. So that's a Scarecrow, very similar to the one on Mars, except no instrumentation. So where are we now? We're headed to Mount Sharp, or at least the Mount Sharp entry point, and this is on July 9th, and it had gone at that point in one day 135 feet.
Woohoo.
That's really
That's its biggest drive.
that's a very large drive, and so here they are. This is actually a photo taken for the first time by one of the navigation cameras. There are a lot of cameras on board the Rover, and all of them are in stereo pairs. So on the mast, there are 2 high-resolution, one wide-angle, one telescopic camera. Those are called the mast cam. There are 2 navigation cameras, also for stereo vision. On the front of the Rover, there's something called the hazard avoidance cam in the front. There's actually 2 of them there for stereo. In the back of the Rover, there's 2 more of those mounted down low. There is a descent camera called MADI that was mounted on the side of the Rover on its hip. And then there's one more camera that's mounted on the end of the arm. So there's a lot of cameras on the Rover. And this is the first time they've used the nav cams because all the other cameras were working just fine. But they had to eventually look at these cameras and make sure they were working properly. So there you can see the arm in front. So this is looking forward and headed up to Mount Sharp. And so that was July 9th. Let's move forward in time a little bit to July 16th. Still headed to Mount Sharp. And again, here we are at the 1 kilometer mark. So 1 kilometer, about 8 more kilometers to go until we get that Mars entry point.
That's about 5 miles, right?
About 5 miles, yeah. So it's a long way to go. So it's about an 1/8 of the way here on July 16th. On July 23rd, it's a little bit further. This is the longest drive, 100 meters, 300 feet, over 300 feet in that day, moving at that speed. So that was a really, really long drive. And this picture was taken with the MALI cam. It's a microscopic camera, but it can also focus out to infinity. This is mounted on the arm. It's on the turret on the arm. The end of the arm has a turret of instruments. It has the MALI, the microscopic hand lens imager. It has the drill. It has the alpha particle X-ray spectrometer, and it has a sand sorting device. And it has I forgot the name of that. It has the Swiffer.
Yeah.
Yes.
Sweep off a little dust.
What was the name of that instrument? Now I've forgotten it. Everything has an acronym at NASA, and I've forgotten the acronym of that. Oh well.
Dust removal tool?
The dust removal, very good. The
it?
DRT, the dust removal tool. You are good. So from looking down at Mars, the mast cam then looked up, and there are things that are moving around Mars besides our spacecraft, which you probably wouldn't be able to see from the surface. There's this. Mars has 2 moons, one called Phobos and the other one called Deimos, which means fear and terror, which are the 2 moons that accompany Mars, the god of war.
That's right.
So here is a sequence of images they took from the surface using the telescopic mast cam, and here you see the moon Phobos moving in front of the moon Deimos. And so this is pretty dramatic. I mean, think about our moon. Our moon's actually fairly large in our sky. Very few planets have moons that are actually as large as that. And actually, we can compare the size of these moons compared to the size of our moon in the sky. Let's take a look at that.
Yeah.
So here, you see a slide that has all 3 moons as they would appear from the surface of their planet. So our moon on the right-hand side is about 1/2 degree across. It's not very big in the sky, actually. It seems bigger than it really is. It's only about 1/2 degree across in our sky. And you can see that Phobos looks in Mars' sky about 1/4 of the size, and Deimos would be just a point to, you probably wouldn't be able to see much of the diameter of Deimos. But it's a lot bigger than it would be if it was orbiting at the same distance as our moon. As you see, our moon orbits out there at 250,000 miles, but Phobos orbits only about 3,000, almost 4,000 miles from the surface. That's much closer. It's orbiting much closer, so it looks a lot bigger to anyone standing on Mars. As a matter of fact, it orbits around Mars so fast, because it's so close, that it orbits around Mars faster than Mars turns. So Phobos actually doesn't rise in the east and set in the west. It rises in the west and sets in the east, just to confuse everyone on who's standing on Mars.
That's really confusing.
Yes.
I would say, too, these are 2 of the smallest moons in the entire solar system.
Phobos, the close moon, is only about 14 kilometers across. It's actually shaped like a potato. It's not even round. It's so small, it doesn't have enough gravitational pull to pull itself into a sphere. Our moon does. Our moon's over 1,000 miles in diameter. So that's one astronomical event that they saw from the surface of Mars. And the other one is one that Robin loves because, go ahead.
Just because I do.
Because
so there was an eclipse of the sun from Mars, and Ron and I have traveled all over the world over the course of the last 15 years to broadcast total solar eclipses, but they've always been from Earth. So I was really excited. We had captured images of an eclipse from the surface of Mars. So this is Phobos. And notice again, one of the great things about living on Earth is that when we have an eclipse, which is when the moon moves directly between us and the sun, it perfectly covers, just amazingly, it's the right size and the right distance to completely cover the surface of the sun. Up on Mars, again, because it's a little bit small, Phobos only covers a partial part of the surface. But it's pretty beautiful. This is the same eclipse taken over 3 seconds. So they're about a second apart, each of these images.
That Phobos covers, even though we saw in the previous slide that Phobos looks like 1/4 the size of our moon, it seems to be able to cover about half of the sun. But that's because Mars is farther from the sun, and the sun looks half the size it does from the Earth. So you can't quite cover the sun with Phobos. And our moon, the fact that our moon covers our entire sun most of the time during our lifetimes is pure coincidence, because the moon is actually moving farther and farther away. So eventually the moon will not be able to cover the sun, and we'll have only annular eclipses where a ring of sunlight always comes around the edge of the moon. An annulus, a ring of sunlight, will always be seen around the edge of the moon. You can find annular eclipses even today on the Earth where if the moon is farther away because it's in an elliptical orbit and we're closer to the sun, so the sun looks a little bit bigger to us, you can have an eclipse where the moon does not cover the sun, just like you see here. So that's an annular eclipse. Back to Mars. So the rover drives around, usually by the operators in Pasadena, saying, go here, and then go here, and then go here, and then go here. They drive the rover. They don't drive it with a joystick because there's a time difference between Mars and the Earth, so you can't just drive around. You have to kind of know where you're going. But the rover also has the capability to drive itself. And just recently, on August 27th, the rover was put on autopilot. And autonomous driving is where the folks at JPL say, I want you to end up over there, you figure it out. If there's some big rocks in your way, you got cameras. You have stereo cameras. Not only can you tell how big those rocks are, you can tell how far away they are, where they're positioned. If there's a big rock in your way, drive around it. So they did the first autonomous driving on August 27th. So that's kind of cool. And so this is, again, more on the way to Mars. This is looking forward. And this is from a series of pictures taken from the front of the rover. So here we are again, driving along. This was as of, again, August 27th. the first autonomous drive. You can see at the very top of the frame there, they had, there's 2 stars. One of them is the blue star is the Bradbury landing site, and the darker blue star there is the Glen Elgary, where they spent 6 months looking at the geology. And now they're driving southwest, and you can see they're right now at the green star along the way. Well, that was on August 27th. They were at the green star on the way to the first waypoint, which is labeled in this photo with a green triangle. So that was on August 27th, and you can see the pathway. They've already chosen pretty much the pathway to avoid large objects, craters and large rocks, which they can see from orbit. But you can always see better, you can see details that are smaller rocks when you're actually on the ground. So this is just guidelines right here. So moving along. Here they are near waypoint 1, and I know that the geologic formation in the middle has a name, and I've forgotten it. So, but they didn't look at it anyway, so don't feel bad about forgetting that waypoint.
Right, the waypoints were places where they thought maybe we'll want to stop and look.
Right.
Like it looks kind of good from the satellite. But when the rover got there, they said, nah, let's keep going.
Here they are at waypoint 1, and they looked down and they found sedimentary rocks, again laid down by water billions of years ago, and cracks had formed in the sedimentary rocks and were filled by later flows of water, replacing some of the material that was there with new material, and that's what you see in this photo. You can see the size there because there's a penny in the photo. Get some feel for the size of those features.
It's also interesting, I love the way that at the beginning of this mission, the scientists were so cautious about talking about surface water on Mars. They didn't even really want to talk about it. And now it's just so common, like you go around and look at things and they're saying this was a lake bed, this had flowing water, this was a lake.
You can see riverbeds with tumbled pebbles, yeah.
So it's just fully confirmed that at some point a long time ago, there were large lakes, oceans, rivers flowing across the surface of Mars.
So one of the big questions that they had found on Mars was methane. And the Curiosity rover was used to try and determine whether there is any methane on Mars. Methane on Earth is produced mainly by biological processes, though you can produce it geologically as well. And but if you find methane, that's a real big sign towards life. And so there's an instrument on the rover that can look at the atmosphere and try and measure methane. And that instrument is called SAM, which of course is an acronym. This is NASA after all.
Of course.
SAM stands for Surface Analysis at Mars. And inside of this, actually you can see this silver tube on the upper right-hand side of this photo. That's the instrument that we're going to talk about in a moment. But this package, about the size of a large microwave oven, has 3 instruments in it. Here you see it from the side. And let me label those instruments for you. So here you see the 3 instruments. On the top, that thing labeled SSIT, that stands for Solid Sample Inlet Tubes. I forgot that one. I had to actually look at the slide to find that one out. The Solid Sample Inlet Tubes, those 2 red things stick up through the surface of the top deck of the rover, and where they actually will deposit soil samples. But they can also take gas in through those as well. And then inside there's 3 instruments. One's labeled QMS for Quadrupole Mass Spectrometer. Underneath it is a gas chromatograph, and on the side is the TLS, or Tunable Laser Spectrometer. So there's 3 instruments. Normally would take up a bulk of a large chemistry lab, but they're all here in the size of a microwave oven on board the rover. And this is a whole chem lab here. It's really quite spectacular what they can do. So bring in some atmosphere, throw it into the Tunable Laser Spectrometer. What does that do? It puts infrared lasers across 2 mirrors, back and forth and back and forth and back and forth through a gas sample. Here you see, with visible lasers, light bouncing back and forth inside the Tunable Laser Spectrometer on Earth, but it's normally infrared lasers, and guess what they found? No methane. At least there's less than 1.3 parts per billion. ppb. So there's, so far, disappointing, no methane, Using this instrument, though, and refining some of the measurements, looking at multiple samples, they'll be able to refine that a little bit more to less than 1 part per billion eventually. So that's coming up. That's for later on in the mission. So we're going to continue our drive. During the World Series, they arrived at this rock formation called Cooperstown, because Cooperstown's where the Baseball Hall of Fame is. And that's where they called this particular geologic formation. Now, that's about almost where we are today. We did have there was a little bit of a problem on the rover. Just like your computer at home, every once in a while you get the blue screen of death, or on the Mac it goes green, it goes gray and tells you, sorry, you have to reboot. Well, that happened on the rover as well. And this could happen because of cosmic rays, or any number of things, maybe a software glitch. And so that happened on the rover, and they had a warm reset. And that warm reset happened on November 7th, and it took a few days, reset the rover, rechecked everything, made sure everything's running correctly. So on November 10th, a few days ago, is when they could continue their mission. And that's sort of where we are right now. We'll be driving towards the Mount Sharp entry point for, I assume, for next few weeks at least. Yep. And we'll come back to you and tell you a little bit more about that in a few weeks. Before we go any further here, though, this is a special day for us here in our webcast crew. We want to wish a happy birthday to Nicole, our Commander-in-Chief. Where is Nicole? Nicole's back there. Nicole's our team leader. Today's her birthday, so we just want to say happy birthday, Nicole. Here's Nicole standing, by the way, in front of that engineering model of the rover down at JPL. We got to go down there and visit, and they were so nice to us. They let us so close to the rover here. They did. It was almost touchable. The folks down there have been great, really helpful. They've been quite nice. They've given us quite a bit of access to all the scientists down there, and you can see this. You can get an impression for the size of the rover from this slide as well. You can see it's about the size of a small minivan, really. So there we go. I want to leave you with one more thing. What's coming up for Mars? India. India first has a spacecraft that's currently in orbit around the Earth and will eventually boost its way out of Earth's gravitational pull and head towards the planet Mars. It'll be their first attempt at putting a craft in orbit around Mars. We're really rooting for them. And on this Monday, NASA's launching a new mission called MAVEN, which is Mars Atmosphere and Volatile Evolution. And that's going to help answer some of the questions about how Mars's atmosphere has evolved. If there was water in Mars's atmosphere, where did it all go? We think Mars's atmosphere was much thicker than it is today, that it was much thicker, and so this spacecraft is hopefully going to help answer that question. So our buddies at Goddard just came up with a wonderful visualization on what Mars might have looked like before it lost its atmosphere 4 billion years ago. So we just wanted to show you that video. So we'll take you out with that video.